This section is titled Percent Composition as a Conversion Factor. I'm going to come out and tell you that I don't really use it as a conversion factor. Percent composition does have some very useful applications, but I don't really set it up as a conversion factor. Now, question 24, you can cancel. We are not going to work with hydrated copper sulfate. We're going to cancel and cross off number 24. But instead, I kind of want to focus on this concept of calculating the mass of an element in a compound using percent composition. Now, I don't set it up this way. Here they're using percent composition as like a conversion factor, where if you knew that propane was 81.8% carbon by mass, which in a previous problem we had calculated the percent composition, you could use that as a conversion factor in saying that, okay, well, a percentage then, 81.8% would mean that there could be 81.8 grams of carbon for 100 grams of propane, C3H8. And when you calculate 18.2% hydrogen by mass, you can use that as a conversion factor then, that as a percent, I could say that it's like 18.2 grams of hydrogen per 100 grams of compound, C3H8. It's totally fine, totally fine. If this makes good sense to you, then roll with it. However, I do it a little different. And so it's great to see a couple different options, and then you can pick what resonates best with you, what seems most natural, easiest, quickest for you. For example, in question 25, we had already calculated the percent nitrogen by mass in these two fertilizers. So it was about 82% nitrogen in ammonia, NH3, and about 35% nitrogen in ammonium nitrate. Now they're saying, and this is what's a really good application of this percent composition. What if I had 125 grams of each fertilizer? How many grams of nitrogen are in the samples? Sometimes we want to analyze a sample of a compound just for one particular element. Now here's my sample size. I have 125 grams. But how much of that mass comes from a particular element? There are two options. Option one is to just use your percent, but use it as a decimal. So if I had 125 grams of CH3 and 82.22% of it is ammonia, or I should say is nitrogen, well, then just bring that decimal spot back. Like we'll take it out of the percentage, use it as a decimal, and we get that it is like a percent. It's a part out of 100. So if I flip it back 2 spots, 82% is like 0.8222. Boom, done. Just take that sample and then multiply by your percentage, but use it as a decimal. That makes sense, right? 125 times 0.8222. And I'd be looking at about 102 point, I don't know. I might just leave it as 103. The original number that I was given was just a whole number, 125. So maybe I'll just leave this as 103 grams of nitrogen. I think that's the quickest way to find the amount of mass coming from one particular element in a sample. Now, previously, you would have had to calculate the percent composition. So if I didn't know that ammonium nitrate was 35% nitrogen, I would need to calculate that first. But then I can just say, all right, there's 125 grams of NH4 and O3. That's the sample that I was given. And I know it's 35% nitrogen by mass. So 35% of this mass is nitrogen. I'll just flip my decimal spot back 2 places, 0.35. Oh, not bad at all. Times 0.35. So yeah, this time if I go, oh brother, it's like 43.75. I don't know. I mean, the original number had 3 digits, so maybe I'll leave 43.8. And that would be the mass of nitrogen I should find in the sample. Manageable, right? I think it's quick and easy if you understand the concept of a percentage. Let me show you another option, though. This option might, I don't know, be a little bit more work, but I guess it all depends, because previously I did have another step to this, in that I had to calculate the percent composition first. Then this part is pretty quick and easy. Here's another option. What if you had this 125 grams of NH3? And that's a mass, and eventually I want to maybe know like how many molecules are in that sample. Well, we could cancel grams and turn it into moles. And I'd say, okay, well, for every 1 mole of NH3, the mass was, I believe, 14.01 plus the 3 hydrogens, 17.04. Okay, so if you want, you could plug that in your calculator, 125 divided by 17.04. And that would give you about 7.34 moles of this NH3. Okay, well now what if I want to break it down by element? And so kind of like when we were doing molar mass, we look at the formula to say, well, there would just be 1 mole of nitrogen per mole of NH3. And if you want to get fancy, you could say, all right, let's set up another proportion. I'll cancel moles of NH3 and switch it to moles of just the nitrogen. And then I'd say, oh, well, yeah, there's 1 nitrogen for every 1 mole of NH3. And then I'd say, I'm running out of room. But that's okay. Then I could take that 7.34 moles of nitrogen and cancel moles and switch it to grams. Oh, so here my answer was just 7.34. There's 1 nitrogen per mole of NH3. So it's just going to be the 7.34 moles of NH3, which then I could cancel 1 mole and bring it to grams. Oh, okay, interesting. 7.34, I'm going to multiply by 14.01, and bingo. I get, if I round it, exactly the same, about 103, 102.8. You'd get the exact same mass. And so I don't know which is more work or less work, because I mean, the percent stuff is really easy. So if that works for you, then go with what's in red. But if you understand all this proportion stuff and you kind of like that, then go for it too. I mean, because again, even with the red work, I previously had another step. I had to calculate that percent composition. So for example, here I could take 125 grams of NH4NO3 and say, well, let's get that out of grams and into moles. 1 mole has the mass on the periodic table. Let's see, we had 2 times the nitrogen. There were really 2 of them. There were 4 total hydrogen and 3 total oxygen for a mass of about 80.06 grams. Okay, so if I plug that in and solve it for moles, 125 divided by 80.06, I get about 1.56 moles. of NH4NO3. Well, then I could take it one step farther and say, now I want to break it down by element. So I don't want to know moles of the compound NH4NO3. I want to know about moles of just nitrogen. This time, every 1 mole of that giant compound has 2 moles of nitrogen. There's 2 of them. 1 and 2. Even though they're not together, there's still 2 of them. Okay, so now I'd be multiplying by 2. And then I'd say 1.56 times 2 gives me about 3.12 moles of nitrogen. And then I could take that 3.12 moles of nitrogen, cancel moles, put her into grams. 1 nitrogen was about 14.01 grams. Watch this. 3.12 times 14.01. What do you know? I get about 43.7 grams of nitrogen, which is pretty darn close to what I got with the percent composition. And same thing here. I was looking at about 103 grams of nitrogen either way. So pick the method that works best for you. If you're cool with percentages, I can easily find the percent, and then I totally understand the red work, where I can just take that percentage as a decimal and multiply by the sample size. Great, go for it. But if you like the proportion method, then that is another option as well. Both should give you the same answer, and both are totally acceptable on any type of an assessment.